This episode of SciShow Space News is sponsored by Audible. To get started, go to audible.com/SciShow Space or text SciShow Space to 500-500. A little over a year ago, we covered a mind-blowing galaxy on SciShow Space News. It's commonly called NGC 1052DF2, or DF2 just for short, and scientists thought it contained virtually no dark matter. This is a hypothetical kind of matter that's invisible and that doesn't interact with regular matter, but scientists are pretty confident it exists. This finding was bizarre because, as far as we know, you need a good amount of dark matter to keep stars moving the way they do. So this discovery was raising all kinds of questions about how galaxies like this could form and stay together. Some researchers even suggested that if this was confirmed, it would be one of the biggest astronomy findings in years. Except, as it turns out, that discovery was probably wrong. According to a paper published in this month's monthly notices of the Royal Astronomical Society, DF2 is a perfectly ordinary galaxy with a normal amount of dark matter. All that confusion was probably just caused by some fuzzy measurements. In the original study, the authors estimated the mass of DF2's stars based on the galaxy's brightness and distance. Then they measured how other galaxies were moving around it. Normally, that motion can't only be explained by the mass of stars, so you need to add in a certain amount of dark matter to balance things out. But that wasn't true in this case. All those numbers suggested that you needed very little dark matter, if any, to explain the movement of those other galaxies. Unfortunately, though, that distance measurement might not have been all that accurate. And if you go back to the original study, this isn't actually that surprising. In the paper, none of the data seemed to agree on a single figure for the distance, and the authors of the new study point out that some of the methods were used in a range that hadn't been previously tested. In studies like this, that isn't always a sign that everything is wrong, since calculating distance in the giant emptiness of space is hard. It just means that sometimes you need more data. And in this case, that new data led to new results. In this month's study, an international team doubled down on the distance measurements, examining 5 datasets to try to weed out any ambiguity. They looked at the relationship between the colors and brightnesses of DF2's stars, examined similarities with other galaxies and objects nearby, and even compared how much the stars flickered when they were counting them, all of which were closely linked to distance. After all this, they finally converged on a distance that every dataset seemed to agree on, 42 million light-years, instead of about 65 million. That number had huge implications for estimating DF2's mass. With that new data, the galaxy's stellar mass works out to be less than half of what we previously thought, and it's only a quarter of the galaxy's total mass. The rest, then, must be dark matter. This brings DF2 in line with what we consider normal in the universe, galaxies of visible stars held together with a massive, invisible shroud of dark matter. So at least this time, it's back to business as usual. In other news, scientists have cleared up another mystery much closer to home, a mystery about the supermassive black hole at the center of the Milky Way. It's called Sagittarius A Star. It's about 4 million times the mass of the Sun, and it's 26,000 light-years away. The weird thing about this object is actually how little we know about it. We know quite a lot about black holes in general, but we have surprisingly little insight into the one in our own galaxy. For instance, we don't know how it accumulates material or how the disk of stuff around it, known as the accretion disk, actually works. But in a report published last week in the journal Nature, a team from the US has managed to take the first picture of the cool gas in the accretion disk. This confirms something we've believed for years, and the team hopes their discovery will shed new light on how material falls into black holes. To understand this study, it helps to know that Sagittarius A Star is pretty shy as far as black holes go. Some of these things gobble up the dust and gas around them, generating a super hot accretion disk that shines really brightly if you look at it with a radio telescope. That's actually how we got that incredible photo of the black hole in another galaxy that was published earlier this year. But Sagittarius A Star is a little more chill. It's picking gently at its accretion disk and lets out very little in the way of radiation, and little radiation means little information. That's why we don't know a lot about it. We've been able to figure out that the region around the black hole is crowded with dust clouds and roving stars. We've also determined that, theoretically, there should be both hot and cold gases that form a spinning accretion disk around it too. But until recently, we'd only been able to see the hottest gas. It's a scorching 10 million degrees Celsius, so it glows brightly in X-ray light, but it also doesn't doesn't behave like we'd expect. Instead of rotating, this gas just falls towards the monster black hole. So in this new study, researchers set out to find the cooler gas, hoping to find a more structured accretion disk. Using a radio telescope called ALMA, they focused on the specific wavelength of radiation that's emitted as hydrogen atoms form from colliding electrons and protons. This radiation is a hallmark of cooler conditions, and its signal is strong enough to make it all the way from the center of the galaxy without being scattered. In the end, this work paid off. There, nestled in a ring about 1/100th of a light year from the supermassive black hole, was the elusive cool gas that scientists had hoped to find. It's only 10,000 degrees Celsius, which, is not exactly cold by human standards, but it's much cooler than the other stuff. The study didn't only find the gas, though. The researchers were also able to measure the gas's relative movement using what's known as redshift. This is the phenomenon where objects moving away from us look more red since their light waves get stretched out, and objects moving toward us look more blue as their light gets compressed. It's like what happens with sound when an ambulance drives past you blaring its sirens. When examining the cool gas around Sagittarius A Star, the team found that on one side the gas was redshifted, and on the other it was blue-shifted. This, they say, was clear evidence that the gas was rotating, and this image was the first to show that. So for the first time, we've been able to take a picture of the spinning accretion disk around the black hole in our own galaxy, and confirm that yes, it definitely exists. This is a breakthrough for understanding accretion on Sagittarius A Star, as well as its complex interactions with nearby stars and nebulas. If the DF2 study proved anything, it's that other scientists should validate these results, but one way or another, it's been an exciting week in astronomy. If all this talk about black holes and faraway galaxies has made you start thinking about science fiction, I get it. Welcome to the club. Stories are a great way to think differently about the universe, and if you want to listen to more of them, you can download an audiobook from Audible. Many years ago, I read Hyperion by Dan Simmons in physical book form, and I recently decided to download the audiobook, and it's just wonderful to be taken back into that very bizarre and beautiful universe. It may be the best story that's ever happened. And Audible has plenty of stories that aren't science fiction as well. They also have exclusive Audible originals in every genre from sci-fi to journalism. You'll get your first audiobook for free, plus 2 Audible originals when you try Audible for 30 days. To learn more, you can visit audible.com/SciShow Space or text SciShow Space to 500 500 so Audible knows that we sent you.